right, so in stoichiometric conversions, we usually work within one, or so far, we've worked within one molecule. So I'm going to call it molecule A. We know that we can convert to grams using the molar mass from the periodic table. We know that we can convert to like atoms, particles, molecules. I mean, really, this could be anything down here. Marshmallows, because we use Avogadro's number, 6.022 times 10 to the 23rd. We will eventually add more to this. The first step we're adding is a mole to mole conversion. So what if I want to go to a different compound? So let's say mole A, I want to change it to mole B. So this is like if you were given a reaction, if given a certain amount of the reactant and I want to find a certain amount of the product, this is how I would do it. And here I would use the coefficients on the balanced chemical equation. And this mole then has the same things. I can convert to grams, I can convert to atoms, particles, and molecules. So if you want to either rewrite this or take a screenshot, you should probably do that. You can go ahead and pause the video and do that. But I just wanted to give you a little like quick example. If I had, let's say, hydrochloric acid plus sodium hydroxide, and that yield water and sodium chloride, and then balancing it, I'm just going to make sure 2 hydrogen, 1 chlorine, 1 chlorine, 1 sodium, 1 sodium, 1 oxygen, 1 oxygen. So it is balanced with all coefficients of 1. So I could do something like give you 5 grams of this, of hydrochloric acid, and ask you how many grams of sodium chloride that would be. So basically on my little chart here, if this was hydrochloric acid and this was sodium chloride, and I was giving you grams of another one, this is the path I would follow to get grams of the other one. So what I would do is I would first convert to moles of HCl, I would then convert to moles of NaCl, and then convert to grams of NaCl. So let's just say I was going to do that, 5 grams of HCl. Again, when I go from grams to moles, I use molar mass. So the molar mass of hydrochloric acid is 36.457 grams to 1 mole. We did put the grams on the bottom so that they cancel and the moles go on the top. This path that I drew here from from here to here to here, those 3 steps are going to be the top part of our conversion chart here. So I did this first step, which was grams to moles. Now I'm at moles of HCl, so I'm here. I'm going to convert to moles of NaCl. So that's my next step on the top. Moles of HCl need to go on the bottom. And then I look at the coefficient. My coefficient for HCl is 1. My coefficient for sodium chloride is 1. It won't always be 1 to 1. In this case, it is. And then I need to do my last step, which is here, which again, going from grams to moles is molar mass. So I'm going to do the mole on the bottom this time because I need it to cancel, and then grams of NaCl on the top. Molar mass of NaCl is 58.448. So just to reiterate, grams cancel with grams. So that was this step here. I got rid of the grams. Moles of HCl cancel with moles of HCl, so I got rid of that step. Moles of NaCl and moles of NaCl, so I got rid of that step. By the way, there's supposed to be a 1 right there. And then my last step was up here to grams of NaCl, which is what I've calculated here. So if I put all that into the calculator, I have 5 divided by 36.457 and then times 58.448. Remember, if you go below this line, you divide. If you cross one of these lines, you multiply. And I only had 1 sig fig, so my answer is 8.01. So my answer is going to be 8 grams of NaCl. So what that means is given 5 grams of this, I can make 8 grams of this. So that's why we do those conversions, is so that we can predict how much product we're supposed to get. So how much product we're supposed to get is allows us then to see how much product we really got, like in real life in the lab, and then we can determine uncertainties and error and yields and all that kind of stuff. So we'll get into that later, but this is the first step, is understanding this math. Now I could have asked you for grams of hydrochloric acid, and then I could have maybe asked you for like particles of sodium chloride. Then you would have taken this path here. I could have asked you, maybe I gave you molecules of hydrochloric acid and I asked you for grams of NaCl, so then you would take this path. So you're really just following the path. It's always going to be like a 3-step thing like that, where you have your given and then you have like your first arrow, your second, and your third. So it's always going to sort of follow the same path. The molecules will change. Maybe what you're looking for is going to change. The only real new step we're adding is this step, this mole to mole ratio, which again is the coefficients on our balanced chemical equation. So coefficients, again, this place is on top. In this one, they were all 1. In the example I did in your notebook, there was one that had different coefficients, so check that out before you start trying these on your own. But that's it for stoichiometric calculations. Please let me know if you have any questions.